Hi everyone, kids. This is Dr. Callahan with Week 2 Wednesday. How are you guys doing? I hope you're having an awesome second week. So go ahead and pause the video and answer the following 3 questions for your warm-up blog. All right, well, let's go ahead and get started with the class for today, the assignment. I hope you guys are logging on a regular basis to go ahead and get this done for your attendance, in addition to your getting your points. Let's take a look at this. In case your computer is not working, you're welcome to go ahead and just do the guided notes and then turn it in. The videos are under YouTube, so you can access pretty much on any device. All right, so with that said, let's go ahead and go over your assignment. So this is for week 2, Wednesday. Week 2, Wednesday, Algebra 1, Semester 2. And you're going to talk about growth and decay, word problems. Your instructions for this class is very similar to any other time. It's for you to watch the video, make sure you view the assignment, and then in addition to that, make sure you go ahead and turn in your assignment. Okay, so here are your instructions. The only thing you need is the YouTube channel for this class. Hard copies are also available outside my class, and you need to make sure you're in class from 8:30 to 9:15 for attendance. Every day you get 10 points. I basically average out the 10 points for the week, and it is always due by 3:30 p.m. the day of the assignment. So let's go ahead and hit it swing. Okay, so next we'll have you guys take a look at your guided notes for this class for today. So if you need to go ahead and print it out separately at home, you have the options of doing so. All right, so go ahead and take a look at this. This is our first page right here, followed by the second page, and then your exit ticket is right here. So I will go ahead and save this, and then I will upload it as well to today's assignment, so that way you guys are able to use this. And if you need to print it out at home, that is definitely a possibility of you doing that. PDF is we're going to be saving this too and save. All right, so let's go back to this assignment. Make sure your assignment is popped up under algebra. And so far it's not popping up for some reason. Let's see what's going on. Yeah, it's here, but it is not popping up over here for your class. which is very, very weird. I don't understand why it's not doing that. Let me close this. Let's try one more time. Oh, goodness. Okay, so Microsoft Teams. Okay, so it's not popping up right now, but that's okay. We'll just proceed on with our lesson today, and hopefully it will pop up eventually. It's kind of weird that's not doing that, but that's okay. All right, you guys. So looking at your guided notes for today, here are your answers as a review of what we talked about yesterday with exponential growth and decay. If you have the x values, you plug into the equation to find the y values, and then you go ahead and graph it. Take a look at the left graph. It is an exponential growth graph versus the graph on the right, which is a linear graph, which represents a straight line. All right, so today, let's go ahead and take a look at the breakdown. So this is what we're going to be talking about. We're going to be identifying exponential growth and decay with equations and graphs. All right, so let's go ahead and take a look at this then. Okay, so we're going to start off right over here where the arrow is pointed at, right there. Equation for exponential growth is, well, that is going to be y equals a times b to the x, where b is always going to be a bigger number than 1. So copy the part that is highlighted in yellow. The equation for exponential decay is going to be y equals a to the b as x as well. However, b has to be a smaller number than 1. So for this instance, you know that a is going to be, if it's going to be 1 over 2, that is going to be a decay because it's smaller than 1. And if it's 3 over 2, it's going to be a growth because it is bigger than 1. A always represents the initial value, and B represents a growth or decay. So pause the video and copy down the part that's highlighted in yellow. And if you're curious what x represents, x is going to be the length of time. X is the exponent that determines how fast something's growing or how fast something is falling down. Okay, so pay attention to the next slide and you're going to be practicing on your own. So looking at this right here, would each of these equations be growth or decay? So looking at them, take a look at the value b. Is it bigger than 1 or smaller than 1? Which ones will be a growth? Well, which one has bigger than 1? I would say that will be 1 and 3. Which one's going to be decay? Has to be smaller than 1. That will be 2 and 4. Okay, so what I want you guys to do is pause the video and then write down, is it growth or is it decay? So you're writing down either growth or decay. Okay, so let's go ahead and take a look at this. So if you look at the first part right here, this is bigger than 1, so it's definitely a growth. Bigger than 1, growth. Bigger than 1, growth. Smaller than 1, decay. Less than 1, decay. And less than 1, decay. So that's how you identify it. All right, now let's take a look at this here, okay? Which one is a decay and which graph shows a growth? First one, it's rising from a small number to a big number, definitely exponential positive growth. Let's take a look at number 2. You're going from a really, really big number high up on the y value and sliding down to a smaller number to 0. Definitely positive decay. Now, what's opposite of positive? It's going to be negative. So in this case, notice how there's a negative in front of it. It's going from something small to really, really big, but you see how it's like flipped over to the other side of the X bar right here? So in this case, it is going to be a negative growth. And of course, the last one, you guessed it, is a negative decay. So this is going to be your homework. So actually pause the video and you're going to write down, is a positive growth or a positive decay? Or is a negative growth and a negative decay? So go ahead and label them. All right, now I'm going to talk about how to find exponents in your calculator. This is a little button that you want. If you want to do something like 2 squared, where it's 2 times 2, you will go ahead and push the 2 button, and then you push this button that has a 2, which is great. But what if you have something that's like 2 to the 3rd power, which is 2 times 2 times 2? Well, you don't have a 3 here, you have a 2. So how do you do that? You push the 2, caret button, 3rd button, enter button, and that should give you 8. Same thing if you want 2 to the 5th power, which is 2 times 2 times 2 times 2 times 2. Push down 2, caret, 5, enter, and I'll give you the right answer. All right, so let's go ahead and take a look at the next part here. Okay, so here are the equations for growth and decay. You need to have a calculator, okay? First question, you deposited $200 in a bank. Every year that account increases by 12%. So go ahead and create an equation for the following. Well, the keyword here is increase, so that means it is going to be growth. So my equation is y is equal to a 1 plus r to the x power, okay? So then looking at this right here, a is always going to be the initial amount before you measure the growth. So y equals 200. 1 plus r is the rate, and your rate is 12%, and 12% is the same thing as 0.12 because you need to put into a decimal. And you just put x right there. X is going to be length of time, 1 year, so let's just put 1. Grab your calculator. Go ahead and add this together to the 1 power and then times it by 200. Let's take a look at number 2. The population apartment is building is 400 people, 4,000 people. Every month the population goes down, so that's going to be a decay by 12%. So looking at this, y is equal to 4,000 people. And then we're going to have 1 minus 12%. Every month, how many months are there in a year? 12 months to a year. All right, let's take a look at the next question here. Next question is, you start a bank account with $500, and the interest in the account is 8% every year. Okay, so obviously your money is going to, get bigger or get more. So y is equal to 500. 1 plus 8% is 0.08 to the 1 power. All right, now let's take a look at this one here. You have practice creating equation. Let's now use a calculator and solve the equation itself. A city population has this many people in 1999. Since then, the population has decreased. So that means it has gone down at the rate of 5.5% per year. 5.5%, if you move the decimal over to the left twice, is 0.05. What is the projected population for 2005? Well, how many years in between 1999 and 2005? There are 6 years. So here's the equation. Y is equal to, started off with 14,358 people. It's decreasing, so 1 minus 0.05. to the 6th power. First thing you're going to do is you're going to subtract inside the parenthesis. 1 minus 0.05 is 0.95. Then you're going to do to the 6th power. So 0.95 caret 6, and then hit enter. That's going to give you a number. Now what you're going to do with that number is going to multiply that number by the 1,000 or 14,358. And that is going to be the answer of the number of people living in the apartment. I don't know why it has apartment. Living in the city is what I meant. In 2005. Now that answer has to be smaller than 14,358 because the population is decreasing. All right, next question. Jim invests $10,000 at 4%, so 0.04, and a rate for 20 years. What will his profit be? So in this case, because it is growing, it's a growth for the money because you don't want to put in a bank if you're not going to get anything back in return. Y equals 10,000. Yeah. 10,000. And we're going to go ahead and take the 10,000. And we're going to do a 1 plus 0.04 to the 20th power. So then grab your calculator. You're going to do 1 plus 0.04, which is 1.04, caret 20, hit enter. That's going to give you a number. You're going to take that number and you're going to multiply by 10,000. And that should give you the answer. And that answer is the amount of money you will have in the bank in 20 years of time. All right, you guys, now that we've tried 2 together, I would like you guys to try it on your own. So you are going to try the next 2 questions on your own. So pause the video and do that, please. All right, you guys, as always, I hope you have a wonderful week. I will see you guys the next time. Stay safe and healthy. Take care.